Hi there. We're going to look at chapter 5, which is straight line graphs. So let's have a look at the chapter. What does it look like? Well, we're going to do more or less GCSE stuff. Slightly harder questions though, related to GCSE maths. Modeling part will be new, and there's also a different variant of question that you're going to see along the way. So really important to make sure your straight line skills are very, very strong, because this is going to come up all over the place. Linear equations are the same as straight lines graphically. So yeah, you need to make sure you understand these points very well. Okay then, so let's remind ourselves first of all what a straight line actually is. So we talked about this in chapter 3. A straight line graphically represents all of the combinations of x and y together that follow a rule. So the example that was given in an earlier video is y equals 2x plus 1. So if we sketch that, which would look something like this line here, the idea is that any coordinates, whether it's whole numbers, fractions, positive, negatives, and so on, they all make this work. So an example of a coordinate that would work would be, let's get rid of that. An example would be 1, 3. Why would that work? Well, 2 times 1 is 2, plus 1 is 3. So this works. So it would be on the line. You should be used to seeing the format y equals mx plus c. So m standing for the gradient, c standing for the y-intercept, x and y staying as variables because those parts can change. M and c are constants. Once you know them, you know them. If you have already seen this format here, so this is another way of writing a straight line, then you're at a bit of an advantage. And where does this come from? Well, if you move this part to the other side, you might see that actually this is really describing how you find the gradient, which is the difference in y divided by the difference in x. This format, so you have that and then you rearrange it to that format there. This format's quite useful for harder questions, which you're going to have more of at A level. So it's very useful for parallel lines, perpendicular lines, and so on. Okay, let's do a couple of questions. So 5a lies on the line. Right, so let's stop there. What does it mean if a point lies on the line? It means it follows the rule. So the 5, if we're following the rule, what is the y value from the 5? Well, you put the 5 in, 3 times 5 is 15, plus 2 is 17. So 5, 17 is a pair of x and y values that are on the line. Okay. Find the coordinate of the point where 2x plus 5 equals y cuts the x-axis. So what does cut the x-axis actually mean? Let's just think about it. This is just a made-up sketch here. But if you're cutting the x-axis, really that means that the y value is 0. It has no height. It's not high up. It's not below. It has no height. So you make the y equal to 0. One way you could do that is you could actually just eliminate it. 2x equals 5. Well, x is going to be 5 over 2. Which is 2.5. Find the coordinate. The coordinate, as obvious as it sounds, you should actually write it as this. It says coordinate, so you've got to write it as a coordinate. If you said 5 over 2, you would not get the full marks for that. Cutting axes then. So cutting axes in general, don't overcomplicate this. Just do a quick sketch and think, what does that actually mean? In general, it will either mean that x is equal to 0 or that y is equal to 0. So determine where the line x plus 2y equals 3 crosses the y-axis. What does it mean when you cross the y-axis? That means x is 0. Okay, if x is 0, 2y will be equal to 3, y is equal to 1.5. This just says where. So we could say here, to be on the safe side, we could write it as a coordinate. X-axis, what is true about cutting the x-axis? Well, that is where y is equal to 0. You don't need to remember any of these things by rote. You just need to think about it. Do a very quick sketch, 2 movements of a pencil, and you'll know exactly that you're working out the right thing. Okay. So what mistakes is it easy to make? Well, it's very easy to mix them up. Why? Because people are looking for things to remember. You don't need to do that. Okay. You've got a grade 7 or above. So you just do a quick sketch, think about what's going on. Okay. So that's kind of a little bit about how an equation of a straight line and coordinates relate to each other. That's what one thing that we can do. So another element that we should look at is gradient. So gradient can be defined normally at GCSE in 3 different ways, or thought about in 3 different ways. But what's the actual meaning? So the meaning is as follows. It's the movement vertically, so that could be up or down, as you increase x by 1. Okay, so this bit here is always 1 if we're talking about gradient. There's no choice in that. So if we go 1 to the right, what happens to the line? Well, it goes up by m, because if you look at difference in y over difference in x, you get m. Okay, so this general idea of difference in y and difference in x is just another way of stating this. Think about if I did another movement. If I did another movement, it would be 2 and it would be 2m. So you would have 2m divided by 2. So when you were doing this sort of difference in y divided by difference in x thing at GCSE, actually, this is what you're doing, okay? So you're thinking, how does the line go up or down as you move 1 to the right? These deltas here, this delta that you see here and here, so capital delta means difference. So it's exactly the same as something like this. You might think, oh, I've seen it written like this. It's exactly the same thing. Okay, or alternatively, you might also see it written like this as well. So any variation of that is fine. It's all gradient. Okay, so let's just quickly check that concept. So we should be able to check gradient without having to do too much work. So difference in y over difference in x. As long as you're consistent with this, you will get the correct answer. So you might think, should I do the difference that way? Or should I do the difference that way? It doesn't matter if you're consistent. So you could do right minus left, for example. It's typically what I tend to do. A very, very basic sketch just to check that the answer is right. Because when you have a negative gradient, you'd be surprised how many people don't get that through laziness. They don't sketch and then they have an answer that's wrong and it derails the whole question, and that will cost you severely. Okay, so if in doubt, a very quick sketch. So what I mean by that is 5, 7, let's pretend 5 7's over there. Where would 8, 1 be then? Well, it would be more to the right and it would be down. So can you see just from that very, very basic sketch, which you are all very capable of doing in 20 seconds or less, that the gradient should be negative. Okay, let's illustrate my point now. So let's do right minus left. So 1 minus 7, and then again with the other one as well. Okay, so right minus left, 8 minus 5. So what is that? That is the same as minus 6 over 3. So the gradient's minus 2. Do you want to see that it works the other way around? Let's do the other way around. So 7 minus 1, 5 minus 8. So what's that the same as? That's the same as 6 divided by minus 3, which again is also minus 2. So as long as you're consistent, it's fine. Quick sketch just to sense check what you're doing. This one here, so 10 minus 2, 10 minus 2 over, I did right minus left, so right minus left again then. So minus 1, minus 2. So I seem to be getting there 8 over minus 3, and that's how I'm going to leave my answer. There's nothing wrong with fractions. In fact, a lot of the time they're better because they're more exact or they're easier to manipulate later on. Show that these all lie on a straight line. So you're thinking, okay, that doesn't look like any of the other stuff. So what's the link? The link is whatever our gradient is here, however we're increasing, should be steady, and that increase should go here as well. There are other ways you can answer this question, but this is what I would look for. So is the gradient from A to B the same as the gradient from B to C? And if you do that, you should get the same gradient. Okay. Collinear means are on the same line. So you might be thinking, where's this coming from? So the idea is they've got the same gradient, and look, they both used B. So it went up sort of the same way both times. Think of A and C there. and B was shared, B was common to them. So therefore it must all be a straight line. They are collinear, they're in a straight line with each other. Right, so y equals mx plus c. What about this thing here then? Ax plus by plus c equals 0. You may have seen this in the transition booklet. This is just another way to write it. Okay, no new meaning really at all. Just another way of writing it. There is a reason why you would want to write this related to things like vectors and matrices and stuff like that, which you might not see if you don't do further maths, but you could still be asked about it. So you need to know how to do it. So this one has been given as ax plus by plus c equals 0. And the idea is we're going to write it in y equals mx plus c form. And the reason we want to do that is because when we do mx plus c, we can easily read off the gradient and we can easily read off the intercept. So what we're going to do, I'm going to first of all move the 3y, minus 3y to the other side, which would give me what? That would give me 3y. Equals, I'm going to flip the left and right side as well. 3y equals 4x plus 5. Divide by 3. Divide what by 3? Divide all of it, which means these two terms. Okay, divide it all by 3, which is 4 over 3x plus 5 over 3. One to watch out for there, how I did that. Okay, if you do adding fractions in reverse, you will see that what I've done there is the same as that. Okay, writing them as separate blocks is quite an important skill, and it will come up in other topics as well. So the gradient then must be 4/3 and c must be 5/3. We can do this the other way as well. So this is y equals mx plus c. The condition normally for writing it in this form is that a, b, and c should all be whole numbers. So a good thing to do is look at this and just think, what's the best number to times everything by to quickly get rid of all the fractions? So here I would suggest, because they're the same, the answer is 3. So let's have 3y. Well, 1/3 times 3 would just be x. 2/3 times 3, you would just lose that bit there. So you'd very quickly get 3y equals x minus 2. Notice everything here is on the same side, so you have to do that as well. I'm going to move the 3y over. So x minus 3y minus 2 equals 0 is correct. I could also move the x and the minus 2 to the other side. So there is an or, so it's this. Or you could say that it's minus x plus 3y plus 2 equals 0. Both of those answers are correct. Okay, they're equally valid. Oh, it's not coming up, but there you go. All right. So if they ask you to write it in that form, then we've achieved that. Okay, equals 0. Everything's the same side. There are no fractions. Have a quick go at the question on the board then. So can you use the same technique? Just pause the video here. Can you get that in this form? So times it by 5 was the way forward. Okay, and then move things over to the same side. So this could be the answer, or minus 2x plus 5y minus 3 equals 0 is equally correct. Okay, so we've now covered 5a and 5b. You should be really quite familiar with this, is the idea. As I said, because straight lines are coming up all over the place. Right, let's move things along a little bit. So instead of using y equals mx plus c, you will use a different format more extensively. We talked about in the previous video that gradient can be thought of as the difference in y over the difference in x. And if you move this up to the other side, you will get this format here. This is a very, very useful format to use for a straight line. Watch out for where the y1 and the x1 is. So when you substitute numbers in, you're going to see something like this generally. So you're going to see y minus blah is mx minus, let's use a different word, shall we? Blah stuff, I don't know, something like that. Okay, so the y at the front stays as a y and the x at the front of that bracket stays as an x. It's the other bits here that you will substitute in. So here's an example.
So find the equation of a line that goes through 3, 5. So that's an x1, y1. That's a coordinate pair. And gradient 2, that's an m. So this is enough information. And in fact, in general, a point and the gradient is enough to find the equation of a straight line. Okay, so it would look like this. The 5, so y minus 5. Please put the y's in the right place. It would be very silly to lose marks because you've written y minus 3. But it absolutely would be wrong, and you'd be penalized very heavily in that question. So y minus 5, 2 because that was the gradient, which is m, and then x minus 3. So let's do this really, really quickly. So in the back of your mind, you should have y minus y1 equals mx minus x1. Okay, and typically we're putting numbers in here. So 3 and then 1, 2 should be y minus 2, 3, x minus 1. Make sure that's all in a bracket, okay? Because sometimes you might have to expand that out. 5, 3, 0. So just think about it. What's it going to be? Put the 0 in first, then the 5, then the 3. So it should look like that. You don't need to write y minus 0. You could just write y. Okay, again. The minus 3 first, y minus 3. Sorry, the 4. Sorry, that's a lapse of judgment there. So y minus 4, and then it was the x. You'd end up with the double negative here. Okay. What are we doing next? So we're doing, so this one we're doing the minus 5 first, aren't we? So y minus 5, and so on. Okay. So you should be pretty happy with how that works out. The mx plus c method, you might want to hold on to that, but it's time to let it go, okay, and move on to the y minus y1. It's a lot more useful for when we have fractions with the new ax plus by plus c equals 0, perpendicular lines, okay. The sooner you embrace this, the better, okay. It's a bit like when I suppose a maths teacher would have said to you at the end of primary to stop adding numbers and start multiplying them or something like that. You need to make this jump, otherwise it's sort of going to hold you back a little bit. Okay, so I said to you just then that you could use a coordinate and a gradient to find a straight line, but that's not the only variation. So it's quite common that they give you 2 points. You use the 2 points to find the gradient, and then you find the equation of the straight line. Okay, so I think we talked about this earlier in the video. So you could do y2 minus y1, x2 minus x1 to find your gradient. You might be wondering why I'm writing y2 and x2. You tend to do this when you're substituting in particular values for each of these, but it really doesn't matter. It's a very minor point. So I'm going to do right minus left. Okay, so 2 minus 5, and then again I'm going to do right minus left over 6 minus 4, which is the same as minus 3 over 2. So that's the gradient. Okay. Let's write out the format now of a straight line before we have a go at the whole thing. So I need the gradient, which I've got, and I need a coordinate. You might find yourself wondering, no, which coordinate? Do I use 4, 5, or do I use 6, 2? And you have to use the numbers together. If you use 4, you must use 5. If you use 6, you must use 2, because we said that they're pairs that go together. So the answer is up to you. It doesn't matter. You'll get the same answer either way, because that's kind of the whole point, is that the coordinates that are on the line always follow the rule. So that's the beauty of the whole thing. I'm going to use 4, 5. So if I use 4, 5, my equation would be y minus 5 equals minus 3 over 2 x minus, so what was my coordinate? 5 is the y, yeah, like this. Okay. I'm not going to do the other one with 6 and 2, but please feel free to do it. You will get the correct answer. What am I going to do over here? Well, I need to write it in this form. So I need integers. The quickest way of doing that is timesing everything by 2. Everything by 2 means that by 2, and then it means that that denominator is going to disappear. I don't do anything else though. On the left, you've got a difference. So if you have like a sum or a difference, you need to do both terms. On the right, I've got a product. So if you multiply a product, okay, you just multiply it once. So let's go over here. 2y minus 10 equals minus 3x minus 4. Okay, from here, I just expand out. So 2y minus 10 equals minus 3x plus 12. Now we move everything to the same side. I'm going to move the x, I'm going to move the 12. So 3x plus 2y, and then I suppose I have to take away minus 22 equals 0. Okay, so this is a good question because it's pretty much putting everything in the whole chapter together. So if you can do this question, you can really do 5A, B, C, I would say. Pause the video, have a quick go at the test your understanding with the same techniques. Okay. So if you use minus 1, 9, you should end up with an equation like this. Or remember, it could also be like that. That's also valid. Little bit more to do. So you're almost there. It's almost time for a little bit of a break. Intersections of lines, chapter 3, you would have talked about simultaneous equations. You would have done some of those with straight lines. We're in the straight line chapter, so it makes sense that we're also talking about simultaneous equations. This is the line y equals 3x. This is the line x plus 2y equals 4. If you wanted to draw this quickly, good tip for you. When x is 0, y would have to be what? Y would have to be 2. When y is 0, what would x have to be? It would have to be 4. Very quick way of drawing straight lines if you know that they're going to cross like this. They intersect at point P. Point P is here. What do you know about this point? Well, you know that this particular coordinate follows this rule, and at the same time, it follows this rule. So you can solve them simultaneously, and it will tell you the answer. They're using a substitution method here. So the y in this part here has become 3x because of the other equation. Gives you an answer of 4 over 7, gives you a y value of 12 over 7. Okay, look at the sketch. 12 over 7 is a bit less than 2. Yeah, that looks a bit like it's a bit less than 2. So what was that? Oh no, the x value, 4 over 7, sorry, is less than 1. Yeah, that still works. It's clearly less than 4. The y value is a bit less than 2. Yeah, there's 2, so it's a bit less than 2. So that makes sense. What else have we got? The line x plus 2y equals 4. So that's the one that we drew here. Intersects the x-axis. What does that mean? It means you cut the x-axis. Aha. So that is 4. So we've accidentally worked that out already. Okay. Determine the coordinate of Q. Yep. So what's the coordinate? The coordinate is 4, 0. Do you notice how I wrote it with a 0? Because they said the word coordinate. Yeah. Then what is the area of OPQ? So OPQ is this shape here. Okay. If you can, base times height. Don't overcomplicate it. No need to do Pythagoras and sine. Yeah, you don't need to do anything like that. Base times height. What's the base? The base is 0 to 4 is 4. What's the perpendicular height? So the perpendicular height is this one here, which is 12 over 7. Okay. So there's 4, there's 12 over 7. Times them together. Don't forget to divide by 2, please. The answer should be 24 over 7 square units. Okay. Right. Pause the video, have a quick go at those ones there on the board then, and you are then finished with 5 ABC. Pause the video and have a go, please. Okay, part A was quite similar to the test your understanding from before. So difference in y, difference over x. Gradient should be 3/4. Substituting into the line, use the y minus 1 technique. You don't really want to do the mx plus c because we said that's a bit slow. Make sure that your final answer has only integers, please. Again, you could also have the equivalent answer. So the equivalent answer is minus 4y plus 3x plus 15 equals 0. Second part, so the line L2. So L1, L2, it's good to keep track of what's going on. This is a different line, okay? This is a different straight line. Find the points of intersection. Intersection, that's a big giveaway for simultaneous equations. Solve them together simultaneously and find a coordinate. X equals 3, y equals 6 is what you're looking for. Okay, so well done. You've made it to the end of 5A BC, and we'll be back in the next part.